Alright, so this will be the second half of the chapter 9, and again we're still looking at the mathematics of spiral growth, and we're looking at gnomons and spiral growth in nature. This is a pretty short one, so let's get started. So the first thing is, before we talk about gnomons, we got to talk about similar figures. Now, similar figures are figures that look identical, but their size are proportionally different. Okay, so as you see, these angles of these triangles are identical, and the only thing different between them is that one is larger than the other. And to see if two figures are similar or not, what you have to do is you got to take some ratios. So what you're going to do is you'll take the shortest side of both triangles and divide them. So I'm going to go larger over smaller. And you see here I get 3. Okay. After that, take another pair of sides, so 48 divided by 16, and again I get 3. And then I check the last one, 15 and 45. We can do that quick math in our head, and we see that is also 3. So since all the sides have a ratio of 3 when we divide them, that means that these two figures are similar. Okay. If all the sides have the same ratio when divided, or they're all scaled up the same amount, then two figures will be similar. Right. And again, the angles have to be the same and everything. All right. So those are similar figures. Now, with that, we can go on to gnomons. Now, gnomons is usually denoted with a G, and in this PowerPoint, what I'm doing is that the gnomon will be in blue. And basically, the gnomon is the attached section to a figure that makes the new figure, that when you add it together, when you attach the gnomon to it, makes the new figure similar to the original. So as you see here, if the orange section here, the orange section A, is our original, if we add, let's say, a 1-inch ring around it, okay, so we've added a 1-inch ring around the whole circle, that 1-inch ring would be called the gnomon. Okay, it's the section that is being added into it to make another similar figure, just larger. Okay, so that would be that gnomon, would be the ring around. Now here we've got a pentagon, and so as we see, our purple is our original. When we add this section up here, this blue section, that is our gnomon, because when we add that, it makes the figure similar, just a little bit larger. So again, the gnomon is like the puzzle piece that we add to it to make a new figure similar to the original. Okay, so this might be able to help clear it up. So if we have figure A, which is our original, and then we have our gnomon G right there, if A is our original, we want to make a similar figure to A. Okay, what we're going to do is that we would take A and we'd slide G onto it to make it a new figure. Okay, and that would be our new figure. And as you see, this new triangle that we've created is similar to the original smaller triangle A. Okay. And the G, or the gnomon that we added to it, made those two, made it larger, so that was similar. Right. So when you're doing these, you usually will be given some sort of dimensions, or have to find dimensions, how much will you have to add to it, type of thing. And again, all it is just getting a ratio. So if you had a 6-inch side and you wanted to scale it up by 2.5, by a scale of 2.5, all you're doing is you just go 2.5 times 6. So that would be 0.3, drop the decimal, 12, 15. So your new side would be 15 inches. Okay, so all it is just multiplying and scaling it up. Right. Now, after the gnomons, it goes into the last section is about spiral growth and gnomonic growth. Spiral growth is what you've probably seen a lot if you've seen the golden spiral, you know, and right here where it's got the image of the hurricane that it's slightly mashed up with, it's not perfect, or a nautical shell. All right, so these are examples of different spiral growths. And as you see, it starts from a center and then it moves outward, okay, and it's connected the whole way. Okay, so you could take your pencil and you can trace it all the way around. That would be a spiral growth. You can start from the middle and you can work your way out. And it could grow out. It could grow out evenly, so adding an inch to it, or it could grow out fast, or It could start off fast and then end slow. Alright, so there's different ways of doing it, but as long as you start like from the center and then you spiral out, that is a spiral growth. Okay. Now the other one, gnomonic growth. Gnomonic growth is basically if you have like a tree stump, or for those of you that have ever seen a vinyl record, you'll see, you can see like the outer edge of it and then the paper. Okay. And then you've got the inner circle. So as you see there, we've got a couple circles that never touch. Okay, we can draw, and they never intersect with each other, or they're not connected in any way. This is a gnomonic growth. All right. As you see, you just keep adding some sort of ratio around it, building it up around and around and around. That is a gnomonic growth. It's kind of like if you think you throw a pebble into water, how you see the ripples go out. That's kind of what a gnomonic growth is. It's moving out in all directions. Okay, it's not a spiral. So that's gnomonic growth and spiral growth. Okay. So the slight difference. Again, there's more examples that you can find, and yeah. So that's it for chapter 9.